This is an Intel server board S1200 BTS, I believe, and it has a bit of an issue, as you might be able to tell. This corner of the board has been crushed, probably by dropping damage. I bought this board very cheap and I intend to use it in a server, but this crushing issue causes the power button to, well, not work. I've measured it up and you simply get no pull-up voltage on the power button pin. I've seen no other issues with the board, although I haven't tested the hard drive LEDs and power LEDs and stuff like that. But yeah, there's obviously an issue with power button, and if we beep out the power button pin on the front panel header, we get a beep on the middle via there. And it's a bit difficult to see on my Tagan Knot microscope, but there's a big flare in the entire board. It's probably been dropped straight down onto a hard surface with this corner first. You can see I can even put my lead all the way inside there. I'm not really looking to remedy any other issues, since the board is working just fine otherwise, but we do have a bit of an issue since there's this plastic standoffy thing right in the corner here, absolutely covering up the damage. So this is probably a blessing in disguise, because it's probably taken a lot of a beating when the board crashed, preventing further damage to the SATA ports. But we're going to have to remove this, and we're going to have to do that very carefully, because it's adhered to the broken part of the board. So it's not going to be entirely safe removing that, because I fear this part is just going to come with it. As you can see, it's already loose. Well, let's give it a go. What could possibly go wrong? So I'm just going to try and cuff the adhesive between the broken part of the board and the plastic foamy gluey tape stuff they've used. I think we can just rip the rest. There we go. That's how crunched VS right there. So I'm guessing that we're just not going to have any connection in the middle via going across the board. So let's just beep that out and confirm it. That's a power button, middle via, no connection. So now we've just got to find the trace. That is properly mangled, but it does seem to be running up in this direction. It's all going under the foamy stuff. Yeah, there are certainly no traces going off in that direction. It's all going over there. So the question is, where's the centre via going? I do believe all three of those vias go to those three traces, snaking their way off. So how part of the middle one has to be. There's one along the edge, going around the corner. There's another crack there. Alright, just dirt. Around the corner. Pause for Chinese characters. Wow, this thing is moving across the entire board. Maybe that one. And I think we've got we can use as a test point there. So that would be there, I do believe. If we beep that to... Yep. That actually beeps to a V at the broken part of the board. So does that beep to the power button? It does not. So that's quite confirmed. The V is just broken. So I'm just gonna go the ugly route and patch a wire from the power button pin header to that V we just tested it over there. Where is it? Okay. And I think after we do that, we're gonna have a board which powers on just fine. So I'm just gonna scrape that a bit, make it a bit more solderable. It's insane how the only thing my old camera does well is being an electronics microscope, because the optics in the new camera just doesn't have that range. It's a bit of extra flux. There we go. And tin the wire and stuck on that. And that's going on pin number 4 after the hole. There we go. I think this board will power on now. I've hooked it up with a power supply. I don't have a processor or any RAM for this, but it should power up anyway. The board is set to power on automatically upon power received from a power supply, so it's going to probably power on right away, no matter what, but we should be able to measure a 3.3 volt signal at the power on pin, which wasn't present before, and we should be able to turn the computer on also. So let's power this on. It doesn't seem to power on. That's weird. Do we have our voltage? We do. 5 volts there. That's higher than I expected. I believe the reset pin was 3.3. Yeah. 3 volts there. 5 volts there. Weird. Oh well. Let's see. If it's connected to a 5 volt standby, we'll get some sparks, I suppose. And the board is not powering on. Alright, I'll swap to that dodgy power supply. Perhaps that one wasn't doing too well. Let's see. We'll power on. It won't. Well, that is certainly odd. Now, perhaps I'm not experienced enough with these boards. Perhaps it actually requires there to be a processor installed for it to power on. I don't have one at hand, except for the 2500K, my video editing machine. Alright, let's just tear that apart and see if that makes a difference. And that went horribly wrong, because this piece of metal which holds my cooler in place drop down this capacitor, which has now ruined my video editing motherboard. There's a good chance that cap's shorted now. Oh, lovely. Oh, well, let's just cut our losses and get this thing in here and see if it works. The board should really be in good working order. I had it up and running just the other day. I tested it prior to purchasing it, and it ran just fine. Now granted, supposedly this processor is not supposed to work in this board, but someone said if I put non-ECC memory in it, it'll work anyway, so let's try it. I'm not going to need this, but let's just put it there anyway. And just for the heck of it, let's just hook up a display as well. Since we in theory have a complete working computer here. Oh well, let's ruin him even more. Let's break 2 motherboards today. Right, yeah, here goes nothing. Oh. Well, that's more the expected behaviour. Yeah. It's not pairing on. Or is it? Well, that's just a power supply being a dick. Fan control's working, but we're not getting any picture of the monitor. Yeah, that's just as expected. I did not expect this to work, but at least now the board's powered on, so we can test the power button, which is why we are here. So let's just measure it again. Pin 4. 5 volts. And will it turn on? Turn off? It turns off. And will it turn on? Well, I do believe that is a fix. Previously we had no voltage on the power button pin, and the device would neither turn on nor off. And well, we're not getting in the picture because we've got the wrong processor. We can at least provoke a response out of a power button. Excellent. But yeah, at least we now have a confirmed test that an i5 at least 2500K will not run in this motherboard. Because if that were the case, we'd be getting some picture, and it would turn off at one tick of a power button. We would have to hold it in for 4 seconds. So alas, we are still forced to purchase a Xeon processor for this thing, but at least now we can turn it off. Alright, I just spent quite a bit of time trying to navigate Intel's new website to find a manual for this board in order to decipher these status LEDs, which pretty much led me down a path that throws some rather cryptic error message reading Northbridge PEI module start, and I have no idea what that's supposed to mean. But I did figure out that if I take the RAM out, we actually get a beep code. So it's quite obvious that the processor is actually running, because you need to have that in order to have beep codes. So yeah, I'm supposing it's just Intel being evil and preventing me from using my 2500K in this thing, even for diagnostic purposes. But well, at least the board runs. Alright, so while we're at it, I figure we'd give it a go, just trying to figure out where the other broken vias go, since there are actually 3 broken vias that you might be able to see, although the one furthest to the right might not be bad, since it's just so close to the crack. Let's just trace them out. The one further to the left seems to be quite straightforward, because it just runs along the edge of the board there. Let's see where he goes. To the second one. Oh, it's okay. Is that going to one of the pins on the USB connector, perhaps? Oh, there we go. It's going to via a bit away from the USB connected just passes straight underneath the actual USB. That's weird. So it's crossing over to the other side of the board. Middle via there. Should be that one. Yes, indeed. And it's the 1, 2, 3, 4th one there. Ah, these are tiny tracks. Is it going to one of those three? Yep. They're going to the other side of the board by the PCI connector. And that's our little row, I do believe. Yep. And it snakes its way forward. Over there. To the other side of the board. Should be that one. Yep. To the other side of the board. Thank goodness we haven't had this rated for any inner layers yet. And it's going to that transistor. And I do believe that transistor is going to that hard drive LED header. That seems like it. So that would be some kind of control for the hard drive LED. Righto, let's try and patch that up. We just have to find some kind of suitable place to come to onto the other side of the board. Or rather on the other side of a crack. Oh well, we're missing a chunk there. Seems to be the 8most track, so let's just follow that. It's taking a similar route to our power button. Going to that via over there. Yep. So we will patch that via to one of the other vias where we found our track jumping layers. We should be good to go for the hard drive LED as well. So let's see if I remember correctly. It went to one of these three. Yep, middle via there. Let's just mark that out. That would likely be that one. So this one should go to the hard drive LED. I know it's not going to go to the header, it's going to be diode drop, but it's going to go to that transistor. Yep, we have our via. So we want to patch that one to that one, I do believe. Scratchy scratch. On an absolutely unrelated note, it's going to be interesting editing this video up because I'm shooting this at 4K, but I'm going to render it as 1080p and try and leave myself some room for cropping. because the wide-angle camera is not well picking up too much detail without cropping, I don't think. So it's going to be interesting. See how well that works. How many days I need to render the video afterwards. I can't wait too long. Okay. Another wire. So we should now have continuity all about for the hard drive LED. Which means this should connect to here. This should connect to that transistor over there on the other side of the board. Indeed. That would be via number 2 fixed. Just one more to go. So that one running. It just seems to be the third trace running in parallel with the others. Let's hope it's that one, because it's going underneath the SATA connector, so we can't see it very well at all. It's that one, number 3. Oh, come on. Go through a via or something. I want to beep you. There we go. That via right there should end up at a broken board. And yes, it does. So there's the one right by the corner of the Wimbond device, and let's just see if that one's actually broken, because that one's quite far into the crack. It could actually have made it. Oh, it's fucked. So we're gonna have to fix that one as well. But that one at least isn't going straight to the front panel. Let's see where it goes on the other side, because it's likely to just go straight to the chip. And yeah, it's so crowded with vias and stuff on there. It's going to be horrible to trace out. So if we can't figure out where exactly it's going, it's no big loss. I'll just fix it anyway. This one closer to that end of the board. And it's trace number 3. That's going to a VA over there. That's handy. Let's just confirm that we're not on the wrong track. So it's right by our other lead. So we will need to find the via on the underside of the board. It shouldn't be too difficult. There it is. There we go, it's marked out. Let's just verify that we're on the right track. Let's beep this back to a crack. Yep. And as a side note, I have paired up my editing computer again, and it still works, thankfully, despite the dented cap. I'm not sure if it lost any capacitance or reliability, but I'm just going to keep running it. I'm not going to bother ordering a new one and replacing it if it runs. Scratchy, scratchy. Fluxy, fluxy. Get on there. And the other end. Let's try not making a mess out of my other joint. There we go. And we'll just flip this so I don't have to have my soldering iron straight over my other joint. This is so awkward. Very awkward. There we go, that seems to be stuck on there well enough for me anyway. Yeah, not going to be going anywhere. It's going to be a bit trickier in the other end though, since it's so packed with ears there. Where are we? Yeah, I'm just going to put a bit of Capiton tape over that because I think we're going to bridge those two vias otherwise, since the wire's going to be going straight over them. There we go, that's good enough. Come on, I don't need any dog hair in my soldered joints. That is not on there. Seems a bit wonky, but yeah. It's a quite large wire for the size of a via, so it's going to be a bit unstable no matter what you do, but at least now we might have some connection. Let's just beep it. So we should be beeping. Let's just trace this out for a little bit and go to another via so that we're sure we're making a good connection. There we go. That's beeping to a via bit just further away. Now that should also be beeping to there, and it should be beeping to the other side of the board. If we can manage to get our probe in there. Yep, that is looking excellent. I've no idea what that does still. But I do believe we're starting to have a somewhat repaired board. I don't think we have more than those 3 vias which have been damaged. There are a couple more right by the corner of a crack there, but I don't think those have been damaged. But we should probably beat them just in case, since we're doing this anyway. It's easier said than done. That's just so cramped with the SATA connectors. Oh yeah, that one beeps okay. And the other one beeps okay. So yeah, those two are fine. I don't think there's going to be anything in any of the inner layers of this board. So I think we're good to go. I'm just gonna take these jumper wires down and wait for a processor and some RAM, and in perhaps a few weeks we'll be doing a build video on turning this thing into a rendering server. So thank you for watching. Cheerio.